The recent editorial notice by the Minor Planets Center announcing that the interstellar object 3I/Atlas has been targeted in a new observational campaign marks a significant moment in the evolving field of planetary defense and interstellar studies. This campaign, initiated by the International Asteroid Warning Network (IAWN), represents the first time an interstellar object has been formally incorporated into a coordinated, United Nations endorsed planetary defense exercise. The decision to focus on 3I/Atlas reflects not only the object's unusual physical and dynamical properties, but also a growing recognition within the scientific and policy communities that interstellar visitors demand a higher level of scrutiny than ordinary comets or asteroids bound to the Sun. Interstellar objects arrive without warning, travel at high velocities, and may exhibit unfamiliar behavior, all of which challenge existing models of detection, tracking, and risk assessment. IAWN itself is a global collaboration that brings together space agencies, observatories, research institutions, and individual astronomers with the shared goal of protecting Earth from hazardous near-Earth objects. Its mandate includes detecting potentially dangerous objects, refining their orbits, characterizing their physical properties, and ensuring that information is rapidly shared among the international community. By targeting 3I/Atlas, IAWN is expanding this mandate to include objects that originate beyond the solar system, thereby acknowledging that planetary defense is no longer limited to native asteroids and comets. This shift reflects the reality that interstellar objects, while likely rare, may pose unique risks due to their extreme speeds, poorly constrained trajectories, and unfamiliar compositions. On October 21, 2025, the date of the solar conjunction of 3I/Atlas relative to Earth, IAWN released an announcement outlining the rationale and structure of a dedicated comet campaign. The announcement emphasized the inherent difficulties of cometary astrometry, particularly the fact that comets are not point sources of light. Their extended comae and tails can distort centroid measurements, leading to systematic errors in positional data and, consequently, in orbit determinations. For planetary defense purposes, even small astrometric errors can propagate into large uncertainties in future trajectories, especially for fast-moving objects like interstellar comets. The campaign, scheduled to run from November 27, 2025 through January 27, 2026, aims to address these challenges by introducing and standardizing improved methods for extracting accurate astrometry from comet observations. A key component of this initiative is a preparatory workshop focused on techniques for correctly measuring comet astrometry. Participation in the campaign is restricted to those who attend the workshop, underscoring the importance IAWN places on methodological rigor and consistency. This approach highlights a broader lesson in planetary defense. Coordinated observations are only as valuable as the quality and reliability of the data they produce. By using 3I/Atlas as a test case, the observing community can refine tools and practices that will be essential for responding to future objects, whether they originate within or beyond the solar system. The timing and substance of the IAWN announcement are particularly notable in light of a white paper submitted to the United Nations on September 30, 2025, in collaboration with Omer Eldadi and Gershon Tenenbaum. That white paper called for the coordination of global scientific research to maximize observational coverage and ensure optimal monitoring of interstellar objects like 3I/Atlas. It argued that such objects should not be treated as mere scientific curiosities, but as potential agents of high-impact, low-probability events. In particular, the white paper emphasized that while the likelihood of an interstellar object carrying extraterrestrial technology may be small, the consequences of such a scenario would be profound enough to warrant serious consideration. This perspective aligns with the concept of black swan events, which are characterized by low probability but extremely high impact. In the context of interstellar objects, a black swan scenario might involve an object that is not purely natural, or one that behaves in ways that current astrophysical models cannot readily explain. The argument is not that such scenarios are likely, but that ignoring them entirely would be irresponsible given the stakes involved for humanity's long-term future. The IAWN campaign can therefore be seen as an implicit acknowledgement of this reasoning, even if its stated goals remain firmly within the bounds of conventional planetary defense and observational astronomy. As of now, 3I/Atlas has displayed a set of unusual characteristics that have earned it a rank of 4 out of 10 on the so-called Loeb scale, which is designed to quantify the likelihood that an object may have a technological origin. While a score of 4 does not imply strong evidence of artificiality, it does indicate that the object exhibits multiple anomalies that merit closer investigation. One of the most striking of these is the alignment of its trajectory with the ecliptic plane of the solar system to within 5 degrees. Given that interstellar objects are expected to arrive from random directions, this alignment has an estimated likelihood of only 0.2%, making it statistically unusual. Such alignment could, in principle, be coincidental, but it nevertheless stands out as an anomaly that invites further scrutiny. Another surprising feature observed during July and August 2025 is the presence of a sunward jet or anti-tail, emanating from 3I/Atlas. Unlike the apparent anti-tails sometimes seen in ordinary comets due to projection effects and viewing geometry, this feature does not appear to be an optical illusion. Instead, it suggests active processes that are not easily explained by standard models of cometary outgassing, which typically produce tails directed away from the sun under the influence of solar radiation pressure and the solar wind. While unconventional jetting behavior can occur in natural comets due to localized activity or unusual compositions, the persistence and orientation of this sunward jet add to the object's list of peculiarities. Taken together, these characteristics underscore why 3I/Atlas has become a focal point for both scientific curiosity and planetary defense planning. Even if all of its anomalies ultimately receive natural explanations, the object serves as a valuable stress test for existing observational capabilities, data analysis techniques, and international coordination mechanisms. The IAWN campaign provides a structured framework within which astronomers can refine their methods, share insights, and collectively improve their ability to characterize complex and unfamiliar objects. More broadly, the attention given to 3I/Atlas reflects a changing attitude toward uncertainty in space science and planetary defense. Rather than dismissing low-probability scenarios outright, there is a growing willingness to explore them systematically, using empirical data and rigorous analysis. This approach does not require belief in extraordinary explanations, but it does require openness to the possibility that the universe may still surprise us. Interstellar objects, by their very nature, represent material from other planetary systems, carrying with them information about environments far beyond our own. Studying them carefully is therefore not only a matter of defense, but also an opportunity to expand our understanding of planetary formation, astrophysical processes, and the potential diversity of matter in the galaxy. In this sense, the convergence of the IAWN campaign, the UN White Paper, and the unusual properties of 3I/Atlas can be seen as part of a broader maturation of humanity's relationship with the cosmos. As detection technologies improve and more interstellar objects are discovered, the questions they raise will increasingly extend beyond orbital mechanics and composition to encompass issues of risk management, global cooperation, and long-term survival. The case of 3I/Atlas illustrates how scientific observation, policy deliberation, and philosophical reflection can intersect around a single object moving silently through our solar system, reminding us that even rare visitors can have an outsized impact on how we think about our place in the universe.